to the AP Chem 2022 FRQ video series. Today we'll be solving question 2 of the 2022 AP Chem free response questions released by the College Board. Whenever a question pops up on the screen, please pause the video and read it to yourself. Part A asks if the hydrogen atoms are oxidized or reduced. So in order to figure that out, we need to think about oxidation numbers. So here we can see that the hydrogen on the reactants side is bonded with nonmetals. And because of this, the rule for that is that hydrogen is going to have an oxidation state of +1. Now, when we come over to the product side, we see that hydrogen is in its simple elemental state. And we have to remember that hydrogen is a diatomic gas, so this is indeed the simplest elemental state. And this is going to have an oxidation number of 0 as per our rules. So hydrogen atoms are being reduced because H has an oxidation number of +1 on the reactants, 0 on the products, indicating a gain of electrons. For part B, we're going to start with the elements we have and list out the number of valence electrons for them. Carbon has 4 valence electrons, and oxygen has 6, giving us a total of 10. So what I'm going to do is I'm just going to start placing bonds between the elements. So this is a triple bond. Carbon and oxygen cannot share more than this many electrons, otherwise it would not obey the octet rule. So now when we do this, we have 6 shared electrons, so that gives us 4 left over, which we will just place as lone pairs on either side. Now, part C gives us a table. So what we need to remember for delta S is that it's going to be products minus reactants. This is very, very important that you do not mix up this order. And now we're just going to plug in our values from the table, and remember that hydrogen gas had a coefficient of 2, so its delta S will be multiplied by 2. And here I used the brackets, not as concentration symbols, but as mathematical grouping, just to make sure that I do the subtraction correctly here to give us our final answer of 220. In this next subpart, we have to calculate Gibbs free energy. We're given the temperature. Remember, we were given this standard enthalpy change at the beginning of the question. So let's just write that here so we have that for reference. And of course, our delta S was just solved in the previous part. That was our 220. So now we have all our information organized. Let's start with the formula. This is the Gibbs free energy formula. You definitely need to know how to use this AP exam. Now we're just going to plug in our values. Now our final answer is 7.50. Part D shows us a particle diagram. So when they say representative sample, they're really talking about the ratio. So what is the ratio of these substances when they are at equilibrium? Well, the best thing to do with these kind of questions is just count them out. So I see 1 methanol, 3 carbon monoxide, and 6 hydrogen gas. All right, ratio, and now it's asking us to find the partial pressure of carbon monoxide. And then when the total pressure is 12 atmospheres. So you need to think in ratios because that's what they gave you. They have the total pressure here. So now that makes me want to think, oh, let's find total moles. Well, that's going to be, let's just say it's 10 moles, right? So now I can say for every 10 moles of mixture, I have 3 moles of carbon monoxide, and I can multiply that ratio by the total pressure of the mixture to get the partial pressure of carbon monoxide, which is 3.6 atmospheres. So in part E, they are now asking us for expression of the equilibrium constant, Kp. Notice the subscript P. This means pressures. This is important. Do not use brackets in your expression because that is incorrect. It is asking for partial pressures instead of what we usually see as concentrations. So remember, this is going to be products over reactants. Partial pressure of carbon monoxide, and of course we are going to be raising these to the power of their coefficients. So our H2 had a coefficient of 2, which is why it's being squared, and of course we have our methanol in the denominator. Done. So part F, we need to calculate the value of the equilibrium constant with the new temperature. So that means we have different partial pressures, and we will just be plugging these in to the expression that we derived in the previous part. Now we can look at part G. Now we know that when volume is doubled, so when volume is doubled, pressure is halved. We already know that. That is Boyle's law. So this is something that you need to know going into the exam. Okay? So now when we're looking at the reaction quotient Q, well, now all the partial pressures are going to be halved because that is what happened in our reaction because of the volume being doubled. So here, what we can do is we can think about this mathematically. So now we can sort of pull out all these 1/2 and write our reaction quotient in terms of K to see whether number of moles are increasing, decreasing, or remaining the same. So of course, if I simplify this out, this turns out to be 1/4. So that's 1/2 times 1/4 over 1/2. Okay, so now we have Q is equal to 1/4 the rest of what we had over here. We can recognize that this over here is the same thing as Kp. So therefore, now Q is equal to 1/4 of Kp. Because of this, now we can say that K is greater than Q. And because of that, this reaction is product favored. So moles of methanol decrease. That's all for this video. Thank you for watching and good luck studying.